Good morning to all. I am Dr.T.Ezhilarasu, Department of Chemistry, Faculty of Arts and Science, Bharat Institute of Higher Education and Research. Today we are going to discussing about the allied chemistry topic, Unit 2, polymers. What is polymer? A long molecule made up of lots of small molecules is called as a monomers. That monomers is combined to form a polymers. So introduction. The polymers are very large molecules made up of hundreds of monomers joined together to form a long chain. This is called as a polymers. The word polymer becomes a Greek word. Poly means many and mer means parts. A polymer is used as a synonym for the plastic. All plastics are polymers, but not all polymers are plastics. The monomers for ethylene, there are a lot of hundreds of ethylene molecules are combined to form a condensed to form a polyethylene molecule. This is the polymerization process. The definition of polymer. A polymer is a Greek name for poly, many means mer, part. A large molecule or macromolecule composed of a many repeated subunits. Due to their broad range of properties, both synthetic and natural polymers plays an essential roles in everyday life. The polymers range from familiar synthetic plastics such as the polystyrene to natural polymers, biopolymers such as DNA, proteins that are fundamental to biological structure and function. The polymers of both natural and synthetics are created via polymerization of many small molecules known as a monomers. Consequently, the large molecular mass relatively to the small molecule compounds produce the unique physical properties including the toughness, viscoelasticity, and a tendency to form a gases semi-crystalline and rather than the some of the crystals. The common examples of polymer. The polymers are two types. One is natural occurring and synthetic or man-made preparing the polymers. The natural polymeric materials such as the hemp, shellac, amber, wool, silk, and natural rubber have been used for centuries of years. A variety of other natural polymers exist, such as a cellulose, which is the maintained consistent of wood or paper. The list of synthetic polymers, roughly in order to worldwide demand, includes the polyethylene, polypropylene, polystyrene, polyvinyl chloride, synthetic rubber, phenol formaldehyde, resin or bakelite, neoprene, nylon, polyacrylonitrile, PVP, silicone, and many more. More than 330 million tons of the polymers are made every year in the 2015. Now itself also preparing the tons of polymers. The polymers is a very large structure of molecules is a called as a chain-like nature. One is the poly means the many member and mer means repeated the unit. The polyethylene is repeated unit for CH2, CH2. This is the repeating unit for polyethylene PE. Polyvinyl chloride is a subform of PVC. In the polyvinyl chloride, you have to substitute for the alternate substitution of chlorine ion. One is carbon is attached to the chlorine and another carbon is attached to the CH2, CHCl and CH2, CHCl. This is the polyvinyl chloride PVC. Then next one is polypropylene PP. You are to getting the one is substituted for CH3, CH2, CH3. This is the repeating unit of polypropylene. The polymer the composition. Most of the polymers are hydrocarbons, they made up of hydrogen and carbon. The saturated hydrocarbons is each carbon bonded to 4 other atoms. This is the structure and the structure of polyethylene. This is the repeated unit for CH2, CH2. This is the tetrahedral arrangement of carbon hydrogen molecule. This is the long chain hydrocarbon. Top figure shows the repeated unit of chain structure and other figure shows the zigzag backbone of structure for the polyethylene compound. Next one is natural polymers. The definition. Natural polymer is a polymer that results from the only raw materials that are found in the nature. Some of these natural polymers include DNA, RNA, cotton, DNA, wool, or some of the naturally occurring polymers are given the preparing the polymers to plastic. The molecular structure of polymers. The physical properties of polymers depend not only on their molecular weight, shape, but also depends in the chain structure also. The four main structure is one is linear polymers, branched polymers, cross-linked polymers, network polymers. There are different types of polymers we have to preparing that. One is linear polymers. The polymers in which the repeated units are connected end to end along with the whole length of the chain. These types of polymers are often quite flexible. Van der Waals forces of hydrogen bonding are the two main types. One is interaction between the chains. Some examples of polyethylene, Teflon, polyvinyl chloride, polypropylene. These are the linear polymers for the chain. Next one is branched polymers. The polymer chains can be like the branches, or the fibers may be aligned parallel as well as the fibers. Some of the plastic sheets also possible for the branched polymers. This leads to the inability of the chains packed to very closely together in the another polymer. These branches are usually result in the side reaction during the polymerization of the main chain. The cross-linked polymer means the molecular structure adjacent the chains attached to the covalent bond. The carried out during the polymerization or by the non-reversible reaction after synthesis referred as a cross-linking. The materials often behave very differently from the linear polymers. Many rubbery polymers are cross-linked to modify the mechanical properties. In that case of the often called as a vulcanization. This is the synthetic property for that now organization. You have to prepare the cross-linked polymers, and generally the amorphous polymers are weak or cross-linking adds the strength. The vulcanized rubber is polyisopropene with the sulfur cross-linking. You have to introduce the natural polymer, you have to introduce the sulfur compound to that. This is the vulcanization process for the cross-linking. Fourth one is network polymers. The polymers that are trifunctional instead of bifunctional. There are 3 points, the 3 points of the repeated unit that can react. This leads to the three-dimensional connectivity of the polymer backbone. Highly cross-linked polymers can also classify as the network polymers. Example for epoxides, phenol formaldehyde polymers. Next is a polymer microstructure. Covalent chain configuration and the strength of the one is linear structure. You have to straight like this chain you have to forming the secondary to bonding. Branched polymer means you have to branch further. The linear chain is attached to the side of the branched compound. The cross linked means the linear compound you have to attach the cross linking one each of the linear polymer each another one polymer linear polymer attached. That is the cross linked. Now the next one is network polymer, the direction of increasing the strength for networking. Polymerization, the process of forming the polymer. The linear polymer, the polymer which obtained the simply adding the monomers together to form a long chain for linear polymer. Copolymer means which is obtained by the different types of monomer called as a copolymer. The degree of polymerization dp, it is the ratio of molecular weight of polymer to molecular weight of single monomer. You have to calculate it for the degree of polymerization. See, the one is types of polymerization. Addition, chain polymerization. For one is initiation. You have to initiate for that. You have to create the free radical reaction. In the free radical, you have to forming the monomer CH2 the acetylene CH2 CH2. You have to form a free radical registration with radical formation. The radical is attached to the acetylene monomer to form a propagation. That propagation is another one attached to the another one monomer. So in this form, the propagation. Next one is the termination means the propagation unit of the 2 unit of propagation unit is attached to form a attached to form a combination of the dispropagation you are getting from that one is possible for the N group CH3 CH2 CH2 is the dispropagation. Another one is forming the combination. This is the addition chain polymerization reaction. The based on mode, the polymerization, additional polymerization, same kind of monomers are straightforwardly added. It is rapid chain reaction having the chemically activated monomers. The each reaction setup, the condition for another to proceed. It consists of 3 stages. One is initiation for the birth stage. Another one is propagation for the growth. You have to creating for the radical. And third one is termination for the death. You have to finally you have to getting from the additional polymer combination of to form a polymer. This is the some common additional polymers for the polyethylene, low density, polyethylene, high density, polypropylene, polyvinyl chloride. There are different types of monomer and properties in polyethylene is a soft and wax solid. Film wrap and plastic bags are to forming the polyethylene. Polyethylene is high density polymer is electrical insulation. Bottles and ties. Maybe you have electrical insulation. The copper wire is there. The insulation tab you have surroundings of that different clearly what is made up of that copper wire. Now, this is the polyethylene wire you want to use in the plastic and the bottle. Some of the bottles preparing and toys also. And next one is different grades for that. Now, similar to the LDP, carbon and abstract. Next, polyvinyl chloride using for the pipes and sealing of flooring. The polyvinyl chlorine is seat covers. You are using the seat cover. Polystyrene is used for toys and cabinets packing and formed only. The polyacrylonitrile is used for the trunks and blankets clothing also. The polytetrafluoroethylene is the non-stick surface electrical insulation. Non-stick support cooker and the Teflon is the that place you are using for the polytetrafluoroethylene. Teflon. Polymethylene and methyl acrylate you are lighting covers and the signs and the skylights. The polyvinyl acetate is the latex paints and the adhesive you are using for the polyvinyl acetate. The cis polyisopropylene requires the vulcanization for practical uses. The polycyclopropene not used for the synthetic rubber for oil resistance. Maybe roughly you are getting from the rubbery solid material for the polychlorpyrene. Next, the second one is condensation method for the polymerization. The hexamethylene diamine for the NH2CH2 6 and NH2 group. That NH2 hydrogen is attached to the adipic acid presenting in the COOH, CH2 CH2 a number of acids in the COOH. That acid is combined to form a amide linkage. You have to forming the amide linkage for that. The acid group, one of the OH group is attached to the NH2 group hydrogen to form a to condensation to form a release of water molecule inside the form a nylon 6 for the amide linkage for NH2 CH2 6 NH C11O CH2 4 COOH for the nylon 6 you have to forming that. The condensation polymerization means the adipic acid is the aminocaproic acid for the catalyst you are using for the polyamide to form a polyamide. The water is condensed out of the during the polymerization of nylon you are getting from that. Some of the original monomers materials are the condensed out during the polymerization process. The process is conducted in the presence of catalyst. Water and carbon dioxide are commonly condensed out of, but other the compounds can be emitted, including the HCN or other acids. Some of the condensation polymers they are showing that this is the one of the polyester decron mailer the polyester for that so the compounds is the polycarbonate polyamide uh, polyurethane. There are different types of polymers you are using for the condensation process. The characteristics of polymer: low density, low coefficient of the friction, good corrosion resistance, good moldability, poor tensile strength, low mechanical properties, poor temperature resistance, can be produced the transparent or different colors also possible for to produce the polymeric material. What is the application of polymer means? Medicinal using that many biomaterials, especially art wall, replacement and blood vessels are made up of the polymers like the Decron and the Teflon. The consumer science. Plastic containers of all shapes of the size are lightweight and economically less expensive than the more traditional containers. Maybe you have to transfer to the food now. That time you have to using for the plastics industry, automobile parts, pipes, tanks, the packing material, adhesives, all polymer application used in industrial market also possible for in developing for the polymeric material. Next one is sports. The playground equipment, golf clubs and swimming pools and protective elements are produced from the polymeric material. Next one is that polymer plastics. What is plastic? A plastic material is a usually semi-synthetic solid. Monomers of plastics are they either natural or synthetic organic compounds. So in this case, the plastic is a synthetic material made from wide range of organic polymers such as polyethylene, polyvinyl chloride, nylon, etc. that can be molded into the shape while soft or then the set in the rigid or slightly elastic form. You have to preparing the plastic material. The composition of plastic, one is you have to getting from the organic polymers plus carbon plus oxygen plus nitrogen plus sulfur. This is the combination of plastic. The organic polymers may include for the chalk, starch, ivory dust, wood floor, zinc oxide, including that there are different types of classification of plastics. There are many ways of they classify the plastic. They can be classified considering the various aspects as according to their one is in behavior with respect to the heating, structure, structural there is no changes in the structure. Next one is physical and mechanical properties of plastics. These are the three different type of classification of plastics. The classification of plastics one is the behavior with respect to the heating. One is the thermoplastic and the thermosetting plastic. The structure one is homogeneous structure and heterogeneous structure. Next one is physical and chemical properties. One is rigid plastics, semi-rigid plastic, soft plastic, elastomers. There are three different types of classification of plastic is there. In this case, the polymerization, the simplest substance consisting of primary chemical are known as monomers or monoliths. They are combined or synthesized to form a polymers. By the process is known as a polymerization. The monomer, the world monomer literature means the many parts. A polymeric solid material may be considered as to one that contains the many chemically bonded parts or the units which themselves are bonded together to form a solid material. The two industrially important polymeric material are one is plastics and elastomers. The plastics are large or varied group of synthetic material which are processed by the forming the modeling into the shape. Just as we have the many types of metals such as the aluminum, copper, we have many types of plastics such as polyethylene and nylon compound. In plastic, arrangement of the individual units may be linear or across the class link. Linear, lightly cross-linked polymers form a plastics called as thermoplastics. Heavy cross-linking plastics are called as a thermosetting plastic. Two different types of plastics is there. First, only we have to discuss in the thermoplastics. The these plastics can be softened and heated and hardened by cooling any number of times without changing the properties of material. We have to preparing that plastic. That plastics and maybe out of semi recyclable material and maybe out of changing the shape also possible. This is plastic is called as a thermoplastics. It is thus the possible to reshape these plastics by means of heat and pressure. One important advantage of this variety of plastic is the scrub obtained from old and warm up the articles can be effectively used again. The properties softness and liquefies on heating and hardness of cooling also possible. The retains the shape after the manufacture, suitable for recycling, can be reshaped by the heat also. It may be melted before passing into a gaseous state. They allow the plastic deformation when it is heated. They are soluble in certain volatile compound and some of the organic solvents also. The shell in the presence of certain solvents present in the thermoplastics. Examples and application of thermoplastic material. High pressure polyethylene as applied to rigid material covered with the electrical machines and tubes. Low pressure polyethylene is a elastic material used in the insulation and electrical cables. The polystyrene applied to the electrical insulation, the handles of tools. Polyamide used in the making ropes, belts. The polyvinyl chloride or polyvinyl chloride for the manufacture of insulation material, pipes, and containers. There are different types of application of thermoplastic material using that. Examples of thermoplastic adhesive, acrylates, the cyanoacrylates, epoxy, and the ultraviolet radiation. The acrylates cured for ultraviolet radiation. To protecting the UV radiation in the polymeric material tissue. Next one is thermoplastic material. Where we are using the thermoplastic PVC polyvinyl chloride properties rigid, tough, and elastic to fill up the material. The uses the plumbing, the pipes of sanitary fitting, the manufacture out of this material. Shower curtains, window frames, flooring, and correlated the roofing seats, plastic coating to steel seats, tank and water systems also. There are so many of the application using for the polyvinyl chloride. Acrylic for another next one is acrylic. The properties of glass clear, somewhat the brittle sound when tapped. Using the glazing, bathrooms and sinks also different colorly material you have to preparing for the acrylic of polyvinyl chloride. Next one is polyethylene or polythene. Low density polythene. Properties for flexible and feels like the paraffin wax. You have to preparing that. Uses of bottles, buckets, seating water tanks also. Water tanks also preparing for the polyethylene low density. Polyethylene high density molecule. Polythene is properties tough and hard material. The corrosion than the polyethylene low density used as a large storage of the bottles and the water tanks. You have to preparing for the high density material. Next one is polypropylene. The properties of smooth and rigid, highest of the plastics in floats of water. Uses of sustenance and sink straps, washing machine beds, food containers, appliances, carpenter. You have to using post the polypropylene material. Next one is polystyrene. The solid glassy state at room temperature, but the flow of the glass transition temperature and becoming the solid against of the cooling curve. The pure solid polystyrene jars is a colorless material. Hard plastic of the limited the flexibility of the material. The uses of polystyrene is one is using the refrigerator containers, food trays, packing food, the food containers, disposable the cups, plates, cutlery, CD, and a casted box. In this polystyrene, you are using that material. Nylon is using for the properties as the high density polyethylene, but the smoother to feel. The uses of textiles and bristles, carpenting, the surgical trays and bearings and pressure dubbing. So many of the applications you are using for the nylon 66 also. Next one is thermosetting plastic. This plastic is either originally soft or liquid. They soften once upon the heating. They harden the permanently harden the hard material for the thermosetting plastic. When they are heated in the temperature of 127 degree centigrade to the 177 centigrade, they set up the permanently and further the application it does not alter in the form of softened material. Only you have to soften that material. You have to, there is no heat and then recycling the material for the thermosetting plastic. But at the temperature about the 343 degrees centigrade, the sharing occurs. The thermosetting plastics are durable and strong and hard material for that. They are the available in variety of beautiful colors or colors in the thermosetting plastics also. They are mainly used in the engineering application of plastics material. The properties are permanently hard and heating above the certain temperature. Undergoes the chemical changes during the manufacture only. Cannot be melted and reshaped of this material. The little potential for recycling this material. The examples and uses of polyester fiberglass system. The seat molding compounds and bulk modeling compounds using for the polyester. The polyurethane is one of the thermosetting plastic, insulating the foams, the matrices, coatings, adhesives, carports, and print rollers. So flooring synthetic fibers and polyurethane polymers are used the combining to form a BIHER high functional monomers and oligomers for the polyurethane. Next one is the vulcanized sulfur also. In the synthetic fiber, you have to introduce the some of the sulfur compound also presenting in the cell thermosetting plastic vulcanized rubber. The backlight, a phenol formaldehyde resin used in electrical insulators and plastic ware. Urea formaldehyde form used in the plywood. The particle board and medium density of the fireboard also possible for preparing the urea formaldehyde. Next one is melamine resin used in the workshop surfaces. The epoxy resin used in the matrix component of the many fiber reinforced in the plastics such as a glass reinforced and graphite reinforced plastics for the thermosetting plastic. The thermosetting plastic material is used for the melamine, formaldehyde, and formica. Another name for formica. Properties is the hardest of common plastics and heat resist. This is the hardest of this common plastic and heat resistance also to maintain the heat also resistant control the heat. The phenolics backlight. This is another name for backlight. The properties of backlight is cheapest material, heavy solids, the solid plastic material, fishly small, the small, when the burnt of the dark in color, heat resistant of the backlight. Uses of bottle caps, plastic automobile parts, bonding the plywood, chipboard, and gloves and laminates with other materials also possible for the backlight material. Urea formaldehyde. The property is similar to phenolic but cannot be produced the lighter color. Uses of door furniture, light switches, electrical fittings, gloves and buttons and radio cabinets, etc. There are different electrical items you are using for the urea formaldehyde polymers. The epoxies, the properties of resin and hardener, they used as a additive material for the epoxies. Next one is polyesters. Properties produce the fibers and the films. It is called polyesters are producing the fibers and films used as a reinforced plastics material for the polyesters using the epoxy material. Next, what is the classification according to the structure of atoms? In the structure means one is homogeneous, another heterogeneous. The homogeneous means the variety of plastic contains the carbon chain. That is the plastic. This is group or composed of carbon atoms only in the exhibit homogeneous structure. Only one common carbon atom you have to present. This is the homogeneous. Heterogeneous means a variety of plastics is composed of chain containing the carbon and oxygen and nitrogen and other elements. They exhibit the heterogeneous structure. There are different types of atoms or molecules present in this plastics is called as a heterogeneous. There are two different types of polymer is the homogeneous, heterogeneous plastics. Next, based on the physical and chemical properties of the polymers. One is the rigid plastics, semi-rigid plastics, soft plastics, and another elastomers. Four different types of properties. First properties we have to discuss in the rigid plastic. These plastics have the high modulus of elasticity. They retain the shape and under the interior stress applied to the normal or moderately increase the temperature also. The rigid plastic. Semi-rigid plastic, the plastics have the medium modulus of the elasticity. And the elongation under the pressure completely disappears. Maybe the complete disappears when the pressure is removed for the semi-rigid. Soft plastics means these plastics have a low modulus of elasticity and the elongation under the pressure disappears slowly when the pressure is removed. The soft plastics are available in the large range of colors, sizes, and particularly shapeless. Shape of this model soft plastic, we have to change the recycling material and the shape also. Used in the making the children's toys, example ratless, etc. Fishing by baits. There are different types of shape and you have to children's toys also preparing the soft plastics. Next one is elastomers. These plastics are soft and elastic materials with a low modulus of elasticity. They deform the considerably under the load at room temperature and return to the original shape. When it is load is released, the extension of can ranges up to 10 times the original dimensions. Within this elastomers also you have to change the different types and the different elastic material for the you have to flexible material for the elastomers. What is the next one? Properties of plastic. There are different types of plastic properties in this polymer plastics. They are the light and weight material, only in a light material and good resistant to most of the chemical. They have the high electrical strength. They have the good corrosive resistance for the plastic material. The plastics can be modulated to any desired shape and size also. They can be made, they can be transparent or color material also producing the plastic. All operations like the drilling, swelling, the punching can be done on the plastics. The painting and the polishing is not necessary for the plastic material. The plastics possess excellent electrical insulating properties. The plastics have low specific gravity. They average being the 1.3 to 1.4 for the specific gravity of this plastic material. The PVC, the polyvinyl chloride, commonly abbreviated by the PVC, is the third most widely produced the plastic after polyethylene and polypropylene. The PVC used in the construction because it is the more effective than the traditional materials for such as copper, iron, wood, pipe, and propel application also for the PVC. It can be made after the some more flexible than the addition of plastics. The most widely used being the phthalates. The copper wire, iron wire, you have to molding for the uh, insulating for the PVC in the form of also used in the clothing, upholstery, electrical cable insulation, inflatable products, and many applications in which it is replaces to the rubber. Application of PVC means it is used in the sewerage pipes, other pipe application where the cost and the vulnerability to corrosion limit is use of the metal. Within the addition of the modifiers, stabilizers, it has become a popular material for window and door frames. By adding plastics, it can be become flexible enough to cabling of application of the wire insulator for the PVC. The material comes in a range of colors in the finishes, including the photo effect wood finishes, and is used for the substitute of painted wood, mostly window frames, and double glazing of new buildings to replace all older single glazed windows also. The other uses including the fascia, the seating, and weatherboarding also. The material almost entire in the replaced of the cast iron, or for the plumbing of drainage also possible for the drainage material also using for the PVC waste pipe in the drainage pumps and gutters and downsteps also. The PVC does not contain the pallets, since those of the only added the flexible PVC, nor does not contain the PPA. PVC is known as having the strong resistant chemicals of the against the chemicals, sunlight and oxidation from the water also possible. You have to maintain for the PVC. What is next one is what is the Teflon? It is a high performance fluoro polymer coatings used for the low friction dry lubrication, where the resistance, heat and chemical resistance, corrosion resistance, abrasion resistance, electrical insulation, non-wetting and cryogenic stability, FDA compliance and non-stick application you are using for the Teflon material for the non-stick cooker and non-stick plate natavana you are using the Teflon. Good qualities of Teflon: the extreme heat resistance, very good resistance to hydrolysis, high abrasion resistance, high tensile strength, the excellent dimensional stability also, easy wash and care also possible for the Teflon. Tailor made and vapor or air from the permeability, good resistance against the chemicals used in the laundry industry also using for the Teflon. The characteristic means characteristic of Teflon. One is non-stick, unique electrical properties, and low coefficient of friction, no wetting, cryogenic stability, and heat resistance and chemical resistance also for the Teflon material. Uses of Teflon: one is indirectly using for the non-stick pan coatings, cookware, the carpenter treating for the stain resistant, personal care products, and paint, home and garden product also using for the Teflon. Directly auto using for the threads, artificial lamps, and body parts. The coatings of surgical blades and some of the surgical implants also using for the Teflon material. Next, manufacture of nylon 6 is made of hexamethylene diamine and adipic acid, which give the nylon 6 to total number of 12 carbon atoms and its stem. The hexamethylene diamine is adipic acids are combined with water reactor. This produces the nylon salt. The nylon salt is sent to the evaporator, whereas where the excess of water is removed in this material. The nylon salt goes into the reaction vessel, where the continuous polymerization process takes place. And this is chemical process makes on the molten nylon 6,6. The molten nylon 6 undergoes the spinning process, whereas the nylon 6 is extra you have to send through the spinet of the small metal plate to the fine holes. The nylon 6 is the air cooled to form a filament. In this case, the nylon 6 is the hexamethylene diamine NH2 or CNH2 and adipic acid for the COH or CH2COH. This is the adipic acid you have to react to the condensed to form a nylon 6,6. The release of another one is release of water molecule. This is the ADP equation for the adipic acid reacted with hexamethylene diamine condensed with polymerization process to form a nylon 6,6 for the peptide linkage bond is forming that material. The uses of nylon 6,6. The nylon 6 is used for the following properties: airbags, tires, roofs, conveyor belts, hoses, belts also, and different types of tire material also using the nylon 6,6. It is light material, so it is suitable to be used for the parachutes. It is a waterproof, so it is used to make the swimwear material. It also resistant to water, so it is used to make the machine parts also. Machine parts. Thank you.